Hi, Amit.
Hey Harun, how are you?
I'm well. I'm well. Welcome. Welcome. Is this your first time?
Good. Hi, yes. I accidentally saw, so I just joined.
Thank you. Thank you. Welcome, Victor.
Hi, Victor.
So we'll just like wait a few minutes. Maybe 5 minutes past to wait and see who joins. Welcome, it bro. How are you?
I'm okay, thank you. Good evening. Our days.
Yes.
Have been long time. How are days going on?
They're good. They're good. Yeah, it's been
Okay.
2 weeks, 3 weeks, I think.
Yeah, almost. Yeah, I think two
Yeah.
weeks. Yeah,
Yeah.
and I even missed the last session. I wanted to participate on the morning session, but I was a bit busy.
It's okay. We can't make for all of them.
Yeah, exactly.
I think you like today's session.
Okay.
We're going to be looking at a smart contract SDK, like or one that we've built. It's more or less like a technical demo,
Mm-hmm.
going through a repository for a payment subscription smart contract. We'll go through the on-chain code a bit, just get an idea of the process that went in writing it. Um, Yeah, and what it takes like to connect the on-chain to the off-chain.
Wow, that's great. I think it will really help me because currently I'm working on a project.
Mm-hmm,
It's a blog. It will
mm-hmm,
be 100% based on Cardano. So we'll be
mm-hmm.
sharing knowledge about Cardano, help developers, everything related to a blog, but in a Cardano ecosystem space. Yeah, so
Okay,
I'm still working on it. I think within 2 weeks I'll be launching it and then share the links with you guys. So I'm waiting for your support. And I think in V2 we will be implementing the reward system about articles, where someone can, if someone who likes your article and want to support with one header, 0 point something, that's
mm-hmm.
that will come on the version 2. But for now, we'll first start by launching the blog and see how it works.
Okay, okay.
Yeah.
Welcome, Kat. Welcome. So we'll start in 3 minutes. We're just waiting to see how many people get in. Regardless, even if it's one person, will just start and go on. Welcome, Tex. I can start sharing so that you guys can be going through just a bit of the documentation. Payment subscription. Can you guys see my screen? Thank you. Second. Welcome, Victor. So we can get started. The other people will find us going on. So today we are going to go through like the payment subscription smart contract. We're going to talk about like the process we went to creating it, um, um, what is usually expected when developing, um, and how to connect the smart contracts to the off-chain code. So there will be no coding. It will just be more of going through what it is about, the documentation, and just an idea of how the functions would look like and how to run tests both on-chain and off-chain. So this was a project last year by Anastasia Labs and Maestro. It's the payment subscription smart contract. It was written in Aiken. So before beginning, of course, we were tasked with at least writing the technical documentation for it. One second, let me just open the relevant docs. Not sure which one I'm sharing. Sharing the wrong one. Let me share something else. Oh. Yeah, let me just start with the architecture so that we can go through it. We'll go back to the documentation. So the first thing we came up with was like the architecture. I'm trying to decide like what are the modules that are most important, like for a payment subscription, or rather, what do we, when we think of a payment subscription smart contract in blockchain terms, what are we thinking of? Yeah, under normal circumstances, when you pay for Netflix, you would just pay for 1 month, and your subscription would be activated. So when we are thinking about of it in blockchain terms or in smart contract terms, we think of locking and unlocking smart contracts. So for this particular one, the idea was there needs to be a contract where a merchant or a vendor can be able to unlock funds, meaning like there needs to be someone who's subscribing, who's paying to a contract, and then a merchant who can withdraw from that contract. So for that, we needed at least a minimum of 2 validators. We called them service validator and payment validator. Now, to make it a bit more comprehensive, like a complete system, we added an account validator. This account validator, the purpose is like authentication in Web2, like login. So it would be your access to the entire subscription system so that we can know who's who. In a validator, we usually have parameters. And Aiken introduced the multi-validator pattern, which was like by accident, where we would have like, we can split the multi-validator into one validator. So in this multi-validator system, we had like the mint purpose for minting and the spend purpose for spending from the contract. So for the account, what we need is we need to know who is the individual who's creating an account, or rather the user, who's the user. So for this, we needed to mint tokens, 2 in specific, using the CIP68 metadata standard. What that does is it allows you to mint 2 NFTs at a go, one that goes directly to the validator, and another one that lives in the validator, and another one that lives in your wallet. So they are called the reference and the user token in specific. So the reference being the one that goes into the validator, and the user being the one that goes into your wallet. So the idea is we can track the wallet using the NFT because they have the same policy ID. So for the account, we had 2 functions for minting. We had, like, for the redeemer, we had the mint account where we could create and delete an account. And for spending, we could update the account and remove an account. So for the account here, this was an MVP. It was a proof of concept. So for the datum, we were putting like your personal data. This is not secure by any means, but then it was a proof of concept. So maybe something like Midnight would help with trying to obfuscate like the user details when it comes to something like this. So this datum, which now we put in your email and your phone number as a representation, is what would allow you at least to be able to transact with the account validator contract, so that we can know at least it is you who is interacting with it. So the next one was the service validator. Of course, there was nothing in the parameters. As well, it had the mint option and it had the service option. So the purpose of the service validator is to create a service such as Netflix. Imagine Netflix is wants to use a smart contract. They would come and they would mint, they would interact with this mint endpoint of the service validator to create a service named, let's say, Netflix. So as you can see, we only have one redeemer here, which is for creating the service. When we look at the spending, now spending from the script, we can update and we can remove a service. Let's say after some time you want to increase your service fee for a subscription, what people will pay. This is the endpoint you would interact with, the update service. And if you wanted to remove the service, you would interact with this, of course, there would have to be checks to see if there are funds that need to be refunded back to the user, or the merchant requires some funds if there are penalties. So when creating a service, you need to at least define the service. For that, we used the datum, the service datum. Here, we would define the currencies that the people would use to pay for the service. This is what you're seeing here, the service policy ID and the service fee asset name. All this now is the definition of the asset. This is the amount. The service fee int is the amount. And there would be a penalty fee if the type of service requires of it. Think of maybe an insurance service where you're not supposed, to maybe take out your money or something like that, or money market funds where you're not supposed to take out your money after a certain period. If you take it out, you're penalized. So the merchant had that option of adding a penalty if they wanted. So this was optional. So we also had interval lengths. Interval lengths, think of it like maybe a month is an interval length. If your subscription runs every 30 days, so the interval length would be 30 days. The number of intervals, let's say 2 months, 3 months, that would be the number of intervals. The number of intervals is to keep track more so of when the merchant wants to withdraw from the smart contract. Let's say the merchant has not interacted with the contract for 2 months, so they would come and find like there are 2 months worth of subscription fees that they need to withdraw so that they can pay themselves. And we have there is active field, which was used to set whether the service is active or inactive. So at this point, I think it would be a good chance to ask any questions. If anyone is lost or if we are following, any questions whatsoever, I'm willing to answer. If not, I can go on. Feel free to interrupt. I cannot see the chat to know if there's anyone raising their hands. Also, if it's too complicated, please say it's too complicated. Slow down, Harun, you're going too fast. Okay, means like everyone is flowing. So we have the account, we handle the service, but then there are no funds. That in comes our treasury, which we called the payment validator. This payment validator is essentially a linear vesting validator. What we mean by linear vesting is if you guys know like a vesting scheduled contract, it's more or less the same. The only difference is that now this is happening periodically, like let's say every month, every 2 weeks, depending on the intervals you set here. If you set your intervals to be 30 days, so this would happen every 30 days. The withdrawal, like the ability to be able to withdraw, the end of the vesting period would be after 30 days. So that's just the idea. It's just a fancy word of saying funds are held up to a certain point, but then this happens every month or so on and so forth. So similarly, we had, unlike the rest, we had parameters for this validator. We had the service policy ID and the service account policy ID, the subscription account policy ID. The reason for this is so that we can be able to know who the person who is interacting with this payment validator is using the account policy ID, this second one, and which service they're interacting with using this service policy ID. So as we have been doing, we will start with the mint purpose. So for this payment validator, the redeemer, in the redeemer, you could initiate a subscription and you could terminate a subscription. So these are functions done by the user who created an account here. So once they initiate a subscription, they become a subscriber. And in order to do this, they would have had to deposit a certain amount of funds, and a payments NFT would have been minted. Asking for the GitHub link. Sure, no problem. Let me share the GitHub link. That's what we're going through. Let me even share the one for the off-chain. If we do have some time, we will go through that as well. If not, we will just go through the on-chain code. Okay. So as I was saying, initiate subscription done by the subscriber, and they would have to pay, they'd have to put in some funds. And here we have now the spend purpose, the spending endpoint. This one had a couple of redeemers. This allows the subscriber, now who has already initiated, to be able to extend the service. You've joined a service, you just wanted to test it out, so you just paid for 1 month. You've enjoyed the service, you want now to pay for another month. You would interact with this endpoint, of course, through a UI, hopefully. you would interact with it through the extend endpoint, and this would allow you to add funds to the smart contract, to the payments validator. We have the merchant withdraw. This one is for the merchant to use. This is what the merchant endpoint the merchant would interact with when trying to withdraw funds from the service. Now, after like the interval length has passed, you paid, the interval length has passed, time for the merchant to reward themselves, they would interact with the merchant withdrawal endpoint. I will not get into the nitty-gritties of what we are passing in. These are just indices for that are required for each to pass. If we got into this would last like 3 hours. But I've shared the link to the documentation, to the repo, so that you can go and find out for yourselves. However, if we do get some time, we will look at some of this and how they work. So we can also unsubscribe. The subscriber can also unsubscribe. Unsubscribing does not remove you from the system. What it does is just it only terminates the subscription at that point. And whether the merchant had a penalty in it, had a penalty condition, that would determine whether you would be penalized for unsubscribing. And if you unsubscribe, the penalties now would be deducted, and the funds would be sent to your wallet, the remaining funds. Now the subscriber withdraw. Now this is if the subscriber has anything else that's left. They want to unsubscribe and you had paid for 1 year. It's been 3 months. You want to unsubscribe and you want to withdraw your funds. So you would first unsubscribe. Unsubscribe ensures that you're not part of the system. Subscriber withdraw allows you to withdraw any funds that are locked in the system that were not yet spent. So for the payment datum, the datum that is required while initializing this, we needed a token name for the service reference token name, so that we can be able to track the service within this validator, within the payment validator. We need a subscriber reference token name. The subscriber is now the account holders reference token name, now the one that lives in the account, so that we can be able to know at least who is the one who's interacting with this. And we needed to know the subscription start time and the subscription end. We can predetermine this based on what the merchant set as they were setting the service, and the installments. The penalty datum. So this one had a sum type datum, what we call a sum type datum. What it means is we had 2 datums, and we would be able to distinguish between the 2 datums based on what is contained in them. So the penalty datum was only used when a penalty was being set or a penalty is being withdrawn. That's the only point it's being used. So when beginning to create a smart contract, it is always a good idea to try and structure your smart contract in a way you can easily understand what is required for all the different structures we require. For instance, the datum, the redeemer, the parameters. It's always a good idea to create something like this so that at least you can see what you're dealing with. So other than that, let's move on to something else now. How it all comes together into a nice design specification document. I'm open for any questions at any time. Do not feel like you're interrupting. The purpose of these sessions is for all of us to learn and grow. Not for you to be lost by yourself. If you're afraid of asking questions, or if you're for some reason they have not come to you or they'll come to you later, feel free to schedule an appointment in the developer experience repo. You can find any of us there. If you want to schedule a meeting with me, you can find all our contacts and our calendars there. So let me just share the repo here with you. For anyone who would have any questions later or do not feel comfortable asking right now. Now let's move on to the next thing I wanted to share with you. The design specification document. Now, when I started like working as a smart contract developer, this was the first tasks I was given, was to write a design specification document. I had not known what this is or how to do it. But this experience personally made me feel like a superhero. Because after writing it, after laying down what we have just seen in the architecture, after putting it down into words, what were the expectations of every validator, I felt like I had already built it, even though I had not written a single line of code. So just like we have discussed, this is exactly what we have been looking at, but then now in text format. I do not want to go like in depth. I'll just like highlight bit by bit so that at least we can be able to run a test and allow people to have questions. So what I think is important, first of all, before we get into the deeper details, is the distinction between on-chain code. Here it's architecture mostly and specification, and the off-chain code, which is the transactions. I manually created this with using Excalibur, but then I will show you how they are. So for the specifications for the on-chain code, you will see we had like the system actors I've been mentioning. I've been talking about the merchant and the subscriber. The merchant is the entity who interacts with the service contract. I've talked about it, to create a service and receive subscription payments for the respective service or services. And a user becomes a merchant when they mint and receive a service NFT in their wallet. So this is the person who creates now the service, whichever service you have, the merchant now. The subscriber, this is the entity who interacts with the account contract to create an account and deposit prepaid subscription fees to the payment contract. And a user becomes a subscriber when they mint an account NFT and lock funds into the payment contract. I hope you all can remember what we just looked at. This is just a clearer definition, like for anyone who wants to understand further. So the tokens involved are the service NFT token that determines who's a merchant, the account NFT that determines who's a subscriber, and the payment NFT that determines which account is paying to which service. So basically it tracks the subscription, more or less. So for the smart contracts, when defining them, we define, okay, the payment multi-validator, we will define at least what it is. The payment contract is responsible for managing prepaid subscription. Prepaid, because of a smart contract, we have to input funds first before someone accesses the service. Validating subscriptions and ensuring proper distribution of these fees over the subscription period given the installments. It facilitates the creation, extension, and cancellation of subscriptions, allowing both subscribers and merchants to interact with the contract in a secure and automated manner. This contract ensures that subscription payments are correctly handled and that any penalties for early cancellation may be appropriately enforced. Just like we've seen, we also define the parameters, the minting purpose, initiate subscription, terminate subscription, just like our architecture document. And initiate subscription, we define them. Let me kindly allow me not to go through all of them just to save on time. Terminate as well. Maybe we can just touch on one just to see how a validation would work. So in initiate subscription, this redeemer allows creating of a new subscription by minting only one unique payment token. So this, I would want you guys to imagine a validator, like any Aiken validator. And now these are the validations that we want to execute. So we first write them in text before we start putting them down in code. So we would say a reference input must provide a service datum from the service contract. This is a check we would have to do on chain. We would also say that the subscriber's transaction input must contain the correct account NFT derived from the subscriber reference token name. This is also something else we have to check, and we go on and on like that. Terminating subscription, same thing. Now this was the minting endpoint, and just like we did in our architecture diagram, we separate the minting and the spending. In the spending, what we notice is we usually have a datum which we do not have when minting. So for the payment, like we said, we had a sum type datum. This is a sum type datum where one represents the payment datum and the other one represents a penalty datum. Like we had said, payment is for when someone is paying mostly, and penalty is when the merchant is withdrawing a penalty or when the subscriber is being penalized or paying through the penalty datum. These are all the datums that we had in our architecture, but then now clearly defined for our readers to read for a good developer experience. So the redeemers, we had gone through them: extend, merchant withdraw, unsubscribe, and subscriber withdraw. I think y'all get the gist of the on-chain. So we would do that. That is for the payment. And we would do the same for the service validator, parameters, minting endpoint, the spending endpoint with the datum, and the redeemer. And we would do the same for the account. Account, the parameter has nothing. The minting purpose has create and delete. And to create an account, these are the conditions. And to delete an account, these are the checks we need to put in our validator. The datum, the email, we had talked about it. This was just an arbitrary array. Again, remember security, as this way of doing it allows anyone to be able to read it online. As much as it would be hashed, hashing can always be reversed. So not the best way to store user information. So maybe more security would be needed to be able to store real user data in a validator. In a datum, sorry. Yep. So I want to talk about the transactions next. So this is important because now this is how we expect the off-chain code to work. This section outlines the various transactions involved in the payment subscription smart contract on the Cardano blockchain. So we had talked about creating a service, but then how does it really look like from a diagram perspective? So this transaction creates a new service by minting a merchant NFT. This transaction is performed by the merchant to indicate that a new service is available. So what happens usually is now we would have a user with an address, a wallet, and the wallet, of course, has some ADA, which are, of course, in a UTXO. So for that transaction to occur, we would need a UTXO interacting with this create service redeemer. That's why we have create service here. The redeemer is create service. And we would need this UTXO, we would need it to contain at least a service NFT, and we would need at least one service reference NFT, meaning at least we need both of them to be inputs so that we can be able to create a user UTXO. Oh, sorry, we would need the user UTXO would need to create one service NFT and one service reference NFT so that we would have the user wallet address having one NFT as the service NFT, and now the service smart contract having this service reference NFT with the datum that we had mentioned prior. Yep, and of course the required amount of ADA. So more or less, transactions look like this. Is a simple way of showing how transactions would look like in a design specification document. And like I said, we have a merchant wallet UTXO. So this is this. The address is the merchant address. We have some value of ADA in the address. Then we have some minimum ADA required and any ADA. So this is the input here, just defining it in text, defining the diagram in text. Then we have the minting process where we have a service multi-validator where we can create a service using the redeemer. Same that thing that's happening here. We are defining. We will expect one service NFT, one reference NFT, and the outputs we expect. So this is what we should expect when we are running the off-chain code or testing the on-chain code. We should expect something similar. Now, for the sake of time, I would want to just peruse through this and go and at least show you guys a bit of how now the architecture plus the design document would look on chain, just for a visual, something to just join now the text, the drawings and the text now to actual code. In the meantime, I'm open for questions. If anyone is lost, has any questions, I'm willing to answer any questions at this moment as I open up the on-chain code. Okay. So this took a bit of a long time the test took a bit of a long time to run. So I ran it before the meeting so that we don't spend a lot of time with it. But then I want to go through at least one validator or the validators just for you guys to get a gist of how they look. So here are the documentations, and here is our payment subscription, and here are our validators. And here is our account multi-validator. So like we had said, this account validator is for creating an account. So what we're doing here is we're just getting the transactions, trying to get the mint, outputs and inputs, the policy and the transactions and the redeemer. And we are not doing the validation here. We have created a library with the same name, account multi-validator, here, where we would create the account. So as you can see, we're just passing all the things that are in a transaction, in a normal transaction and validator, into our library function, create account. Let me open it to the right, open to the side, just to make it easy to follow. So we are calling this function here. So we can create an account, we can delete an account in the Mint and endpoint. When we are talking about the Mint endpoint, this is what we're talking about. I wish I could open something else here. Let me see. Too bad my screen is small. I have liked to show this as well. So I want to show this. This. I don't know. Is this too small, guys? Please let me know if it's too small. Because what I want to do is I want to show you guys. Yeah, let me just close this for now. Yeah, let me close this. I want to show you guys the relation. So here we have the account validator. We have create account here. We have create account here. We require the input index and the output index. These are the input and the output. We'll be getting them from our redeemer, which we call Mint account. And this calls now the functions for creating and deleting. Oh, we've closed this, but then let's just open it here, the validation. So for creating an account, and for the validations, all these checks are what we are performing here. All this is open source. I've shared in the chat for anyone who would want to go and look. So here we are looking at output at account address. We need to ensure that the output goes to the account address. Ensure that the output index must be sent to the account script address. So this is the validation here. Is account metadata valid? Just means that we need to ensure that the datum is correct. Ensure that the datum is accurate. Here it is. And output policies are correct. This is just to ensure that the tokens are correct. The CIP68 input must be present to derive unique token names. Validate that exactly one account reference token and one account user token are minted. So basically, this is just to show the relation between the design spec document and the code. That's why I'm saying, like, once as a dev, you are familiar with writing design spec documents, you've literally you've done most of the work, because now it's just putting it into code and ensuring it works. So maybe something else I'd like to touch on. That was the account. Service is more or less the same. Service multi-validator is more or less the same. You can create a service, and in the spend endpoint, you can update a service and you can remove a service. Same thing, we have created the libraries with the same names under the lib folder. Under close this, under lib, payment subscription, we have account, we have payment multi-validator, and we have service validator. So this is what we are talking about. Payment multi-validator, similar as well. We have extend, so we are calling extend from the library, putting in all the values we need. Merchant withdraw, unsubscribe, and subscriber withdraw. I hope you guys can remember. If you can't, luckily there'll be a recording of this on our developer experience portal and also on YouTube. So something else that is cool, before now, starting with the off-chain code, I don't think we'll have time, but then just to mention, before starting with the off-chain code, it is usually good practice to write tests. And we, similar to our validators, we have like three folders, three files: account multivalidator, payment multivalidator, and service multivalidator. All these are tests. This test.ak is just mostly for to write functions that we will be using in our other tests. These are called fuzzy tests. It's really well documented on how to use in the Aiken-Lang documentation. And it's literally creating arbitrary information, trying to simulate the transactions that we have seen in our design docs one by one. So in the transaction section, we'll have to go back here. So in the transaction section, there are all these things we need. We need to ensure like IUTXO has the data, that it is minted, that we have the correct output. So we can predefine those things here. Like we have create accounts fuzzer here. This simulates now all the information we would need to create the account as fuzzy tests. It simulates a user input, now this, which contains an output reference and an output. Of course, it has some values. Of course, it has the address and it has the datum. We have no datum at this point for the user input, and there is none there. The reference script, there is none. The user output, this user output, we also create like a dummy user output for the same purposes, so that at least you can be able to see if the validation works when we run. And it all runs here, it all accumulates here. So I have already run the test, so maybe I can just like take you through the definitions, because it takes about 5 minutes, because the tests were many. It takes about 5 minutes to run, and I did not want to waste your time. So if you know to run an Aiken test, you run the command Aiken check. And these tests are divided clearly. Like you can see here, this is the payment subscription tests for the account multivalidator. So here what we're checking is, we're checking if it successfully creates an account, if it successfully deletes an account, if it successfully updates an account, and if it successfully removes an account. Under this successful, these are fuzzy tests, these are normal tests without necessarily the fuzzers. With this, we can see the memory each test consumes and how big it is, and the CPU, the memory, and the CPU. So as we can see, we had 13 tests for account multivalidator, and they all passed. For the payments, for the payment multivalidator, similarly, we check for if it initiated successfully, terminated successfully, if you can extend successfully, if a merchant can withdraw, if a subscriber can unsubscribe, and if a subscriber can withdraw successfully. If it can fail when trying to initiate with a missing service reference, if it can fail if you have insufficient funds, and if it can fail if you initiate invalid ranges, or if it fails when if it fails to terminate during a token ban. There were 19 tests here, they all passed. And it's the same for the service as well. And more or less, that is how you run tests. So the fuzzy tests are automated tests. So as much as you can see 14 here, 19 here, and 13 here, the fuzzy tests allow to do like multiple edge cases automatically. That's why they all accumulated to 838 checks. checking different case scenarios for you. And if you can do this, at least you would have some confidence that your smart contracts, it has some form of validity, and it does work the way you intend it to work. So this was just an example for how to create a payment subscription smart contract. I hope it has been helpful. I would like to show you guys the off-chain code, but that might take a longer time than necessary. So allow me to leave it at that and answer any questions you guys might have. Yes, Bernard.
Thanks a lot, Harun. This is extremely very useful. So here I want to point out one most important thing which you have done. It is very important to do property-based test here. If you look at why his test took 5 minutes, you will see for each test there are 100 arbitrary values that test each unity test. So that is why you will see here 100 tests. So for each, you are going to have that 100, 100, 100. Unlike what we normally do on what we call our full stack testing. I just create a function, then I use 1, 2, 3 different examples just to test your function. But that is not enough. And in Cardano, it's very important to do arbitrary tests using a lot of edge cases, up to 100 times. So that one, it is very important to write tests in this way. I think for ICANN, it is brilliant because we have got this tool that automates a lot of these cases. So that is what I wanted to stress a lot about, this most important thing. And I have seen a lot of my developers which are making mistakes. They create their own chain code, they compile it, then from there they go and build up their off-chain code. But where are your unity tests? And when you do unity test, the normal unity test done in other programming languages are not enough. Do property-based testing here where you can run for each unity test 100 different arbitrary values, testing all the different edge cases. Thank you very much.
Thank you so much for that, Bernard. Very, very important to run unit tests and property-based tests, especially when building smart contracts. Because we are more so than anything, we need to remember that we are dealing with people's funds. Any more questions, comments, suggestions? Yes, Ian.
Hello, Harun.
Hi, Ian.
I'm new to the Cardano ecosystem and I'm learning how to write this contract. And Bernard went on writing tests. So I'm curious whether the tests are something you can generate using AI. You have to read them word by word.
Sorry, I didn't hear the question clearly. You're breaking up a bit.
Like the tests, are those something which automate using AI or you need to write them word by word?
Well, AI, okay. Now, the issue with using AI or vibe coding for smart contracts, specifically in Cardano, is that we are not yet at a point where, okay, rather, ICANN and smart contracts in Cardano are developing at a very rapid pace. So you might find that the knowledge that the AI models have is not yet up to par with how it's supposed to be used. So there are chances of making many mistakes while doing that if you try to vibe code in any smart contract programming language in Cardano. My suggestion would be to familiarize yourself with like the Aiken documentation and the Aiken standard library, because it has like all well laid out instructions of how to use these things. Unfortunately, at this stage, there is no shortcuts, unfortunately. Maybe it will improve the more people start coding in Aiken and the language models continue learning, because it has, like, from when I started building in Aiken to now, I can conclusively say that the results I get on chat has greatly improved. Still not up to par, but then it will continue improving, but then not yet. And also, as a smart contract developer, just for your own knowledge and skill level, I would advise you to just start by writing them yourself. Come write down an input, write down your own UTXO, write it down so that you understand all the different aspects of a transaction or of a UTXO. Yes, Bernard, please.
Testing is very important. That is why we are always taught, do a test-driven development. Write your test, your code fails. Now go and fix your code to pass your test. If you saw, I was happy, he was happy, all tests passed. Did you ask yourself, why is he happy, all tests passed? Because you have written your code to pass them. It's a test-driven development, which is different from what you are used to. You simply produce your smart contract, it compiles, you think, now everything is all right. But when you have got huge code, up to 1 million different code bases, how does anyone have confidence that that code is okay? Unity test help that. So the best approach is write your test. They will fail because you haven't written the code that will make them pass. And then from there, you go and you test. Then it passes. Then you go on to the next one, up until. Why? Code coverage in testing is very important too. So, and then on the other tools, I'm not an expert in Aiken, but I see the tools they have. They are there on other tools. On other languages, we have got fast check and we have got quick check. The moment you go to that tool and you learn it, then you are done. You might not even need to go to the AI. He is telling the truth about the AI compared to Cardano smart contract development. The AI, whether it's ChatGPT 5.1, it doesn't know Bluetooth. It guesses using the old information it finds on GitHub. A lot of time it is wrong. So it is very important to do the documentation of that language thoroughly. Aiken is a very good documentation. So make it the first starting point. Thank you.
Thank you so much, Bernard. Thank you for that, 8Pro.
Yeah, thank you so much. And it was a very good and interesting expose. I really like it. And I also like the way the project file is detailed, because everything is written there. And when you work on a search file, it's easy to develop because you have everything already implemented, everything written, and you know where to start and where to go. You know, sometimes we got mixed when you just start a project, and when you start mixing things, you don't even remember where you started. Having a search file, I think it's a good point. Yes, I wanted also to add about the test. You know, sometimes people are struggling with the test because they wait to build many functionalities, then create a test. I think a better way is just when you have developed a functionality, you need to test it immediately to see how it reacts, what's the feedback, and that's more easy. And it also helps a developer to go fast. Thank you, Mr. Harun.
Well said. Well said. Yes, Bernard. Well said by both Bernard and 8 Pro. Very, very true. Like, the best way to do this, like even I myself, like with this particular project, I fell into that trap. Like I first of all built the features, and then afterwards is when I did the testing, and I felt like that took me even more time than if I had done it while I was doing it, like when I was writing each particular feature. So yeah, I myself have been like I've failed at that, but then now I make it a point, like when I'm writing functions, I do test driven development. I do the test as I'm writing the functions, so that at least I'm confident when I'm moving to the next feature, it is the one I left is correct. Any more questions, comments, suggestions? If not, I want to thank you all for joining us. There will be another developers working group session on Wednesday at 7 a.m. UTC. I hope like you guys will also come for that. I'm sure Uche would have something different to show. So y'all can feel free to leave at any moment, and thank you again.
Yeah, and for those who are always looking for the meeting link, we now have it on our website. You can just visit the DevX website. There is now a button on Meetup implemented down there. You can just select which session you want to participate in, and you'll get a link for both the session. We have 2 sessions there: the Thursday evening and the Wednesday morning session.
Yes, exactly. Thank you for reminding me, 8Pro.
Thank you.
Awesome. Thank you very much. I really appreciate. Thank you.
Thank you so much for your support, Bernard. I really appreciate you as well. Thank you, guys. Feel free to leave. Just waiting to see if there's anyone with questions. I'll be the last one to leave.
Harun.
Yes, Mwangi, Brad.
Yeah, fine, thank you. I have a question. I don't think it's related exactly to what you discussed. It's more of
Just
a maybe a consultancy kidogo.
No worries.
Yeah. I'm working on something related to Cardano where people can donate to maybe charity using ADA or maybe ADA. But now I have another feature where I need to swap this ADA because I don't want to store the ADA. I want to swap it at runtime. I'm referring to USDM. So I'm swapping the ADA to USDM and so on. But my concern is when setting up these variables, considering that maybe the donation is going to different kids, so they have their own maybe wallets too. They have been set up their wallets. So if I am to set up like the recipient, because the donor is whoever is donor in mwenye anatuma, and the kids are the recipients. So do I have to like set up their receiving addresses like what, assuming we have a scale, watu ni wengi, ama the kids are lots. Is it possible to have like a pool, or I don't know, maybe a pool where the funds can go to then be distributed later?
Yeah, yes, that's possible. It's possible to have a pool where all the funds are collected and then you distribute later. It's also possible to just distribute to each individual person if they all have wallet addresses.
But I don't know. My concern is, you see, right now, maybe right now I can deal with 5 kids or 4, but as at a scale, because it's a product that is actually is going to be used by another organization. Like they requested for it. So
Then I'd suggest this. I've shared here in the link. I don't know if you've seen.
mhm.
There's this developer experience repository.
Yeah.
I don't know if you can see it in the chat. Can you?
It's opened in my tabs up.
Okay. There under the README, there's like the names of the developer advocates there. You can
Okay.
find Harun there, and then you can schedule a meeting, and then maybe we can talk about it more in depth.
Okay. Sawa. I think
Is that okay?
that will work. Yeah. I think that will work.
Okay.
Yeah.
Okay, so
Thank you.
I know, risk, take care. Bye, guys.